Hello, everybody. I'm Steve Johnson. Welcome to Digital Works TV. Our guest today is David Nuttall, who is an artist and more. Now, David, maybe this isn't strictly model-based systems engineering, which is what we're kind of engineering-centric here. But in addition to being an artist, and I guess we ought to talk first about your art before we get into the part where the engineering really comes into what you do. So you're an artist, and you call what you do arty maps.
Yes.
And they are, what are they?
Predominantly hand-drawn, plausible, fictitious places. Short version was real maps of fake places.
Okay.
So I've been drawing maps since I was 5. Fictional places, creating landscapes that look like they could be real.
Okay. So am I correct that when you were in high school in England is a bit, you're from England, by the way, for anybody who hadn't picked up on that. High school in England, that you actually worked, am I correct, for British intelligence drawing maps?
We finished high school at 16.
Okay.
Back then, and I basically went straight to work as an apprentice, equivalent an apprentice at what was called Military Survey, so British government mapping agency. So I was a civilian in the Royal Engineers doing a lot of secret stuff. Eventually.
Okay, so you were a cartographer.
Yes.
For the British military.
Yes.
Okay, so my assumption is if you're a cartographer, this is where we're getting into the model-based systems engineering thing. If you're a cartographer working for British intelligence, they want the roads the right size, the right length, as they relate to every road around them, because nobody wants to be looking at a map, especially not if they're in the military, and say, they have this road, this big old wide thing, and it's not, and they say it feeds into this, and it doesn't. So accuracy of the mapping model would be paramount.
Absolutely. And I was taught using what we call scribing tools, which is a little diamond-tipped chisel, to be accurate to 0.2 of a millimeter.
Okay.
So from engineering folks, they know millimeters. So that's a tiny amount of latitude that you have to be off accurate.
Okay.
Now, the thing with mapping that most other engineering didn't have is you're allowed to have some ambiguity for scale. So if you're trying to show in a mountain valley, there's a river, a railway line, a highway, and then a local road, well, if you draw them all the exact scale, they don't fit. So the modeling there is generalization to make important things look more important, but still fit in the same space.
Okay, so you're saying that your map was drawn so that each thing relates to the other things in it, and
Yes.
maybe not to scale, but to accuracy of relation. Does that even make sense?
Absolutely. Yes, because if you glance at a map, and military is a good example, you need to see things quickly. You can't be looking at a map going, what does this mean? So understanding things intuitively and quickly is very important. So you need to know that the 4-lane highway is a more important feature than the 1-lane dirt road next to it.
Yeah.
If you show them all exactly the same, you lose that immediacy of understanding.
Okay, now these were drawn on paper, am I correct?
They were printed on paper. The whole manual cartography starts with aerial photographs or other source material that you then interpret and scale and extract and print and scribe and draw, and then it's a lot of negative work. So you're working with light on dark. So that's manual cartography, which wasn't the best nutshell description of it, but it was a lot of labor to the point where maps took about 6 months to create. So as soon as you print it, it's out of date, which is where modernization and computers came in, that if you can speed up the process, the map is more accurate for more time.
And and also if they come in and build a new road, you have to go back, I suppose, in the cartography for British intelligence and redo the map.
One of the funnest jobs I actually had, and there's certain things I can talk about and certain things I still can't talk about. Still, yeah.
How long ago, by the way? Well, I probably shouldn't ask that. But no, it's been several years.
It's been a few years.
Okay.
But the Official Secrets Act is for life.
Okay.
So there's some information I have that could still be dangerous if it was out in the world. But one of the most fun parts was, one of my roles was to evaluate a map to see, did it need updating? So you're looking at the paper printed map and then comparing it to what other source material, imagery, information you can find to say, oh, there is a new X. Now, a new road is an obvious one, but on military maps, new power lines.
Yeah.
Anything that would interfere
Or
with
a new
aircraft.
structure along the road.
Anything over a certain height, because then you're infringing on possible aircraft routes.
Okay.
So a new, like, TV broadcast station, the mast, that is not just a mast, it's got guidelines, so that takes up a lot more room in real life than you think it does as a dot on a map.
Okay.
So a lot of things like that would have to be reviewed. Does this mean we need to do a new map? Some maps you could do an overlay. You just print another layer on top of it and get a cheated update.
Okay. But in those days, the maps, it wasn't like okay, let's get to what you do now. Okay, we've got what you did then, and we're going to talk more about your art later. But another thing you do related to your work as a cartographer back in England is you are, and I want to make sure I say this right, you consult with 911 agencies to make maps for response maps for like emergency vehicles.
Yes.
And what does that even mean? What do you do to consult?
Well,
and this is digital now, I would imagine.
Absolutely, yes. So once I left England and moved here, I worked for what was Intergraph, that then became Hexagon. So I would travel to different customer sites. This was when I was an employee, and help them convert their local data, whatever format it was in, into the right digital format so that it could be viewed in the 911 map. Because they don't use Google Maps. When you call 911, their map needs to be a lot more specific and a lot more detailed than anything you can just get.
And it's
online.
on a computer
Yes.
Okay.
Yeah, they're looking. Hopefully people don't call 911 very often, but when you do, it's probably a bad day for you. So the person on the other end has got to extract as much as they can, who you are, where you are, and what help do you need. And the where you are is massively important, because Huntsville's fairly easy, because Huntsville city limits is one jurisdiction, Madison County is another, but the Madison County Sheriff's has responsibility inside the city of Huntsville for certain things. So you can't just say, where are you? Therefore, it's one police department or the other. It's where are you and what do you need? Therefore, that might change who's coming. So the level of nuance in the map data has to be really, really tight.
So is that the nuance? Do you consult on the nuance?
I consult now. So now I'm independent and I help the customers. And I'm trying to make sure that everyone talks the same language is the first barrier, because often the person who needs the map doesn't know any of the language about the technology. They don't know database words. They don't know what to ask for because they don't know it exists. So if you want the map to look better, you might say, I need more names. Well, what you really need is better relationship between the names and the buildings.
Yeah.
So there's a lot of helping people understand what information is available, which means using my knowledge to go troll city websites and GIS databases and say, okay, yes, you can go pull the light rail network out of this open source data and merge it into yours. More importantly, where do you live? What's your address? Do you have an apartment behind your house that has an access from a different street? And then it gets way more complicated than that. I was in DC last week, and it brought back memories of when I worked with their police department. There's 16 police agencies inside DC. And the national park, you're on the mall, that's park police.
Yeah.
The sidewalk is Capitol Police. The street is Secret Service Uniform Division. So whether you are 2 foot one way or the other could be a different police department. So the maps have to be that finite.
And it has to be that final, and it's digital now.
Yes.
So it has to be that final, and you've got to be able to glance at it.
You've got to be able to glance at it and the system tell you information without you asking.
Okay.
So some of the screens will say, whose zone are you in? So in Huntsville, you might say, okay, which police precinct am I in?
Yeah.
Because the West Precinct is going to be a different responding officer than the South Precinct.
Yeah.
But in DC, it's the sidewalk is different from the grass, different from the street.
And the relationship, let's just say with DC, with I'm assuming that if DC is like every other city these days, there's construction going on and changes being made. So that, as would relate to model-based systems engineering, something on the map is changing, and you've got to make sure that that change is reflected on all the other things it changes. Am I correct?
Yes. So the maps are being used by the person answering the phone call
Yeah.
to figure out where you are. They're being used by the person who's dispatching on the radio to the vehicles to help you get there. And it's used in the vehicle to help you figure out, one, how to get there and where to go when you get there. So if a road is closed, so I was downtown in Huntsville the other day and there was a big tent in the street. So someone had blocked a block to do an event. Well, that's a temporary restriction for a day or two. Well, you don't want to send an ambulance through there. Now, going a block out of the way is not going to hurt you, but if that road was the only way to get somewhere and it's a 5-mile detour, maybe a different ambulance should go. So yes, there's really short-term restrictions. There's changes to the road. There's roads that are only passable in certain times of the year in certain places.
Yeah.
If you go to Vermont, once you get to mud season, you shouldn't drive a fire truck down that road.
And the map has to reflect
The map has to know that.
So that's like nature is changing things.
And it has to take into account the vehicle.
Yeah.
Because a 4-wheel drive could get down there. A normal police car might, but a motorbike wouldn't, and a heavy vehicle wouldn't. So you're taking into account the permutations of the road surface, the temporary conditions, and which vehicle should be going through that area.
And that's what you consult about.
Yes. And the fun parts are who can get there the quickest.
Yeah.
So a lot of what I do is trying to make sure the road network, the literal connectivity of the data, is accurate enough for who's using it. So an ambulance service, for example, it's the easiest one to give an example because all the vehicles are essentially the same.
Yeah.
So there's no criteria other than it does also take into account the skills of the person driving the vehicle.
Can it do that? Does it really do that?
Yes. What if you call 911 and you only speak Spanish? The system needs to know to send someone who speaks Spanish. So that needs to know who's driving which vehicle, so which vehicle should come to help you.
That is, but what you're laying out is so complex. So, and that can be done on one digital representation with all the complicated changes and criteria that might change because of the weather. It can do that.
There's basically a static base layer.
Yeah.
So the road is a 30-mile-an-hour road. It's this wide. It's this surface, and it has traffic lights at each end. That's static. Yeah. Well, what if one lane's closed for construction? Well, you can still go one direction. What if there's a reason to slow the road down? Yeah. So you've got temporary restrictions and adjustments on top of that static. And that's, the complication then, whose area is it? Who should go? What vehicle should go? What skills should go? Yeah. It is, there's some depth to this model. Yeah. And that doesn't even get into ambulances have contracts. Ambulances are normally private.
Yeah.
So there's an LLC or an entity. Huntsville Emergency Management is not a public entity. HEMSI is a private business. So therefore, they have a contract that says within this...
HEMSI's been bought by Huntsville Hospital.
Oh, that's true. HEMSI may not be the best example. Normally, Huntsville Hospital is technically a private business. It's not run by the fire department.
Okay, I see what you're saying.
So it's not a public service in that respect.
So the map, this map almost has to be intelligent.
Yes, it's extremely intelligent.
There are so many. So could you even do what you're describing 30 years ago?
Not very quickly. So they used to do it because they had big whiteboards and big maps on the wall, and they would literally go move things around on a wall.
Okay, so but how unwieldy, especially if somebody's life may depend on 5 minutes quicker or 5 minutes slower.
And also that 5 minutes, how is that being measured? Well, now the computer's doing the measuring. Yeah. The vehicle is being told to leave at this time. Therefore, all of these things are time-stamped.
Yeah.
So an ambulance in a urban area has a different response time than in a rural area.
Yeah.
So if you live in downtown Huntsville, an ambulance should get to you within, let's say, 6 minutes. If you live way west in the county, in the unpopulated part, still in the city of Huntsville, the ambulance may have a 20-minute contracted time frame to get to you because you don't live where there's an ambulance. That changes. Huntsville's growing really quickly. So where does that line between dense and urban and rural actually happen? So it's not just the static road conditions, it's growth as well.
Even in Huntsville, which thankfully isn't as complicated as DC, but I mean, the map has to be layered and it has to be complex and layered, but at the same time, quickly understandable.
Quickly understandable and easy to update.
Okay,
and
because if a road's blocked, the map changes that,
Yep.
and that would like anything else, that would change the routes that have to be traveled and might change who's responding. I think you've already said.
Yes. Huntsville's not that complicated in some ways, but it's extremely in others because it's 230 square miles.
Yeah.
So that's a lot of area to cover. So if you send the wrong police vehicle, you could be 10, 15 minutes slower than someone who could have been sent instead. So it's not just how do I get there, which is the best one to go. It's let's now consider where everyone is currently and of their current locations, what are they doing? And can they be pulled off what they're doing because this thing's more important? So there's a prioritization to it as well.
And the map has to be able to do that.
Yes.
Okay.
So it is a giant model, and it is using a lot of
and
tools and algorithms behind the scenes.
And once again, if in the paper days, the paper map days, when we didn't have a digital representation that could change according to how the real world changed, having somebody where the human element would really be huge, where somebody would have the experience, say, tell them they can't go that way, the street's blocked. You don't have to depend on some guy just knowing.
Absolutely. It used to be that to work in police or in dispatching, you had to know the city intimately. And the joke is London taxi drivers has larger brains, because to pass the test to become a taxi driver, they give you random locations across the city, and you have to, from memory, tell them the quickest way to get to and from those places.
Wow.
That's still a part of the test to be a taxi driver in London.
Well, one of the things, I know a guy who's a driver for the Huntsville Fire Department, Huntsville Fire and Rescue, and they have to know. They can't just say, "Well, I know where Governor's Drive is." They've got to know, okay, from here, if I can go to Governor's Drive, but that intersection is blocked, so here's the best way I know how. They had so. Not as bad as having to sit the whole city, but they have to know their area.
And they have to know what they're driving. Huntsville doesn't have the really big articulated ladder trucks where there's a driver at the front and a driver at the back. So the radius of the turn is important to them because they can't make certain turns.
Yeah.
So you start including that. Huntsville has speed tables, calming, speed bumps.
Yeah.
Well, if you've got two roads parallel and one has speed bumps and one doesn't, the one without is quicker. So therefore that has to be attributed on the street.
And we also have steep hills and a couple of mountains.
We're not too bad compared to some parts of the country, but slope, certain vehicles won't get up a steep slope. So a lot of my work has been in California, and the mountains there, they literally have what they call no truck zones, meaning don't send a fire truck up that road because it won't make the slope.
And the map has to reflect that?
Yes.
Okay, so heck, you're more model-based systems engineering than guys working on a missile. I don't even know how this can all be related by looking at a map.
Well, thankfully, most of it is behind the scenes. So it's the attribution, the metadata, if you will, so that the visuals of the map is, how do I find it? How is it clear? I want to know what's immediately around me. So in a vehicle, if I'm sent to an incident, I want to know very quickly, is that a school next to me? Without having to go look to see it's a school. Just colouring it, school bus yellow is what I tend to use because it's an intuitive design. That's the aesthetics. Okay. That's making it look usable, easy to read and quick. And then each one of those features in the map has an attribution behind it. So the building can say how tall it is, what the square footage is. The street can say, is it simply a main road or a secondary road? What's the speed limit? Does it have traffic calming?
Yeah.
And then the network of putting all that together is how you get between those things.
Okay, and as the model, as the network changes, as the map changes, those changes. Like there's a street not too far from where I live. Last week it didn't have traffic calming, has it now? That would need to be reflected.
If they want that, some places don't want that. They want keep it simple and almost let the drivers make the decisions.
Okay.
So some places are a little resistant to the level of technology.
Oh, that happens in model-based systems engineering too. People, we want to go there, but we don't want to go any farther.
And also, this person's been doing it 30 years. Why wouldn't I trust them?
Yeah.
And one of the funniest things I've seen, it's not funny in the moment, is when fire stations go from what they call run card, which is every piece of fire equipment is listed in order of which one can go to get there quickest. If they go from that to GPS-based location, well, then that fire truck may have gone to lunch. He's now closer to the incident than he would have been in the fire station. So you've got to take into account what he's doing and why he's there. But if he's gone to the workshop and he hasn't got a wheel on, you shouldn't send him. But if he's at lunch, you can probably send him.
Okay, so not only as you have a map, but you have GPS location for the emergency vehicles that might have to respond. So that's also included on the information provided by this ever-changing digital map.
And you as a resident, if you need help, you want the closest thing to come to you.
Yeah.
Not the thing that has a territory that has been decided 30 years ago.
Yeah.
And fire stations and fire departments have argued, well, we've always gone to that location so we can get there first. And this other one's saying, well, the system says we can get there quicker. And I've seen those go to
there's pushback.
It's a territory. It's like how we don't. Fire guys like to go put out fires. So if there's a fire, they want to go.
Yeah.
Well, this guy can get there quicker according to the system. And I've seen them actually race. They have gone and said, no, we can get there quicker. No, we can get here quicker. And they do it. And the computer is right.
Okay. And the respondee doesn't care. They just want somebody to show.
If you call 911, you want someone to turn up quickly. You don't care where they came from.
Okay. Wow. So, and this is what you do.
Yes. I help people do that.
So it's
because I'm not taking over for the city.
Did you learn anything in British intelligence that helped you do this?
That's an excellent question.
Accuracy?
I think the accuracy and the commitment to what is accurate, because accurate isn't singular. There's not one best way of doing something. Being the most accurate map could mean it's the best scale map. It looks the prettiest. You've put every small detail on there. But if it's superfluous and then actually hinders a response, removing some data is good.
Okay, so this,
the most accurate may not be. It's accurate for what you need it.
Okay.
So accuracy of, is that river in exactly the right place, matters less than is the boundary in the middle of the river or on the coast of the river.
Okay.
So the accuracy of the data for the response, which is emergency response.
I just recently taught somebody earlier today that talking about use the best thing, not maybe the one that's the most expensive or the most elaborate. And that in the maps you're talking about, that's
yes. You want the most comprehensive data.
Yeah.
So it's better to have data be slightly inaccurate but more current than exactly accurate and out of date.
Okay. All right. I want to talk just before we finish about something. You have ridden your bicycle over every street in Huntsville with GPS and drawn a map of the city of Huntsville using GPS. You've ridden every neighborhood. When I say every street, I mean every neighborhood street. So you've gone every around block.
Yep.
And you have. What did you tell me you had done with that map that you made?
Well, I animated it to start with, so it looked cool, and then I said, well, I've got all this knowledge, I've got information, I should digitize it. So what I've done is I've taken every block and categorized it by how difficult it is to cycle. And I used like a ski map color coding: green for novice and easy, blue for intermediate, red for advanced, black for you shouldn't cycle down the parkway. So color coding each road.
I think that's illegal, by the way. I think we need to get that out there, isn't it?
If it's a limited access highway, it is illegal. The service road.
So you can't like state highways. You cannot buy. You're not supposed to. I have done it before, but not in a long
limited access is the criteria.
Okay.
Where it says no unmotorized vehicles.
Okay, all right.
Which includes horses.
So
by the way.
you've done a comprehensive map of the city of Huntsville.
Yes. And I gave that data to the bike planning group when
Yeah.
the city was doing their bike plan to see which
Yeah.
road should go, because I've had so many people question me. Well, you just posted on Facebook you cycled a Ditto Landing and back. How did you do that without being on a main road or being unsafe?
I've done that.
But you know where to go.
Yeah.
But as someone who's a novice,
Okay.
like I don't want to go up a steep slope. I don't want to go on a busy
Yeah.
road. So my criteria took into account the slope, the number of side streets, whether it was residential or
Yeah.
commercial, the lane width, the speed limit, and the traffic volume.
Okay, so that map, and really every map, you have maps for one reason, to get from where you are to where you need to be or want to be. Am I right about saying that?
No. Maps, that is an excellent point, because maps are often purpose driven. So if you think of historic maps, they were drawn because someone paid for them to be drawn to show power or strength or what they possessed.
Okay.
So colonial era maps were very dominant, even the colors. What color was chosen was to show dominance. It was a specific
Yeah.
cartographic choice. So a map can be, think of them like statistics, visual statistics. You might have a bias as to what statistic you want to be the most dominant. So if you want to show a railway map of America, the railways will be more dominant than the streets.
Yeah, okay, that
So
makes sense.
it's not just for navigation, but that's often the primary use. Some of it is situational awareness. What's around me?
Okay.
I
So,
don't need to go anywhere. What is around me?
Okay.
Is it dangerous to go beyond X? Which in military maps, absolutely. You don't want to leave this area because we don't know what's out there.
Okay, so I'm blown, and we have talked before, but I guess we didn't get into enough about the 911 thing. I'm like amazed. But once again, the bike map, it all relates back. It's like if model-based systems engineering is taking a model and making sure that if you change one thing, another thing reflects that change and still works. I mean, a map's the same thing. It is exactly the same thing.
And even a hand-drawn map is that, because if you change something, you've got knock-on effects. I can't move a road without impacting something else. So even at the absolute most basic level, a model is, to me, anything that has connectivity beyond itself.
Okay.
So I think of model as way more than just one thing.
Okay.
But that's something you like you said, Steve. You've met me. My brain will go off on permutations and tangents.
And okay, so you do all this other stuff. How do you still have time, or why do you still want to draw maps? Maps for fun that are art. And I have one of your maps in my house. It's a proud possession, and it's a real map of. It's almost a place. It's very close to a place we go, and it looks representational enough that I kind of think of it as being that place. But you do these for fun, and they're art. And you sell the art.
Yes. Well, thank you for having one. And your description of it is exactly what I want people to feel. It could be real. It's a feeling of this could exist.
Yeah.
So for a map I draw now, even the one I'm wearing, I'll do weeks of research to make sure what I'm creating is using the culture, the history, the architecture, the transit system, everything that could exist, so that maps I've drawn set in Egypt or Turkey or Iran, I've never been. But if someone looks at it, they feel, oh, that actually feels realistic to them. That's my goal.
Okay.
Why do I still do it? I think one person politely described it as a compulsion.
Okay, well that's good, but I got to tell you that there's more to cartography than I would have ever believed.
We've only just hit the surface. I mean, a lot of GIS now is coding.
Yeah.
So a lot of the new people coming into this field, they need to know Python, they need to know how to write scripts. So I know a lot of database language. So there's a whole technical side under the surface to make a pretty map.
Okay, well, if I was smarter, we could talk about that. Man, David Nuttall, thank you for being with us.
My pleasure. Thank you,
Cool.
Steve.
I feel smarter right now. That's not all that hard to do. But anyway, thank you.
No comment?
Thank you, David Nuttall, and thank you for being with us here on Digital Works TV. I'm Steve Johnson, and don't forget, it works.